Hello, everyone, and welcome to another Monday guest speaker series. Tonight, we have Clay Morton, who's going to be talking about working with Kaggle data sets. So, Clay, can you tell us a little bit about how did you get into data?
Well, I got into front-end development and then kind of full stack development.
Mhm.
And eventually I got interested in data. So it's kind of a new thing for me, actually. I work on the data science team at El Toro, and I do, I guess, mostly data engineering, but some analytics and stuff like that.
Excellent. We've had several of our students go to work for El Toro in various capacities, some through internships, the running of the
Yeah, in
bulls.
fact, there's one here, my new coworker.
There we go. So wonderful. And then you're also a Code Louisville mentor this session.
Yes, in Data One.
Excellent. And is this your first session or have you mentored with us before?
No, it's my first time.
Excellent. Well, we're definitely glad to have you. So yeah, looking forward to this presentation. I'll be here watching the chat. If anyone has questions, we'll have you do your presentation and then we'll have a little bit of time at the end in case there are any questions that need to be addressed. So I'll turn the floor over to you.
All right. Well, I initially proposed this as working with Kaggle data sets, or is it Kaggle? I'm not even sure. But maybe really what I want to share is the fun of data exploration. So Kaggle is a great platform for doing that. Now, it was designed as a kind of contest platform, some kind of predictive model for a particular data set. And I'll start by just kind of showing you all the platform here. Oops, I got screen share. Okay. Okay. So this is, well, sorry, wrong tab. This is kind of the introduction to Kaggle. And they have this competition about the Titanic. And they give you a data set of the ship's roster. So it has the age, gender, ticket price, cabin location, number of siblings on board, and then they have a column of whether that person survived the disaster. So that's a 0 or 1. And that's the training set they give you. And then there's another set, the test set, which they don't give you, which is the same thing, or they give you the training set, but they don't give you the whether the person died or not. So you take the training set and you build some model to predict, whether someone would have lived or died. And it sounds complicated, and you don't necessarily need to use this platform for a competition, but going through this first competition will help you get more familiar with the platform. There's this really great video that kind of tells you how to enter a competition, help. Even one of the things that they mention is that and they walk you through building a model and making your first submission. So what they recommend is after you make your first submission, do some research. So they're actually kind of implying that historical knowledge or domain knowledge of the data set will improve your chances of victory, or improving your model. The tutorial, I know this, and first, this is a sample. So this data set or this answer to the question, this is the test data set with you add your column of 0 or 1, whether the people died or not, is totally based on gender. So it's not a bad guess as it happens. But it's not, you can improve beyond that. So let's see. So this is the code that they start you off with, and it just shows you the various data sets. So we have our training data set here, and this has been indicated with the whether the person survived or not. This is the smaller data set that doesn't have the indication, and this is a sample input just based on gender. Very simple model. Now, the way you load it is the typical method with pandas, and you can find the links above. They have the code that sort of walks through the directory and pulls that out for you. And then you can do a little bit of validation. Once you load data, it's good to validate it. So this is a great method for just seeing, the first 4 lines, and that'll at least tell you that there's some data and kind of what it means. But you might want to do some more analysis. Now, most of these data sets are pretty clean and populated, so you don't have to worry about it too much. But once you get out in the wild, you probably want to do a number of validation steps just to see that you got what you expected and that it will be useful towards the analysis or problem you're trying to solve. So you can see here, what they did was they took women that survived, and it's pretty simple. One of the columns is sex, and it's male or female in this case, and survived is a column that has the 0 ones. So they're getting the rate of women that have survived, and that happens to be 0.74%. So that's the accuracy of this model's prediction, which isn't too bad. And the rate of men that survived. So. And give you code to make a better guess. And so they're using the package scikit-learn. This is really nothing, to worry about. This is more advanced stuff. But like I said, it's fun to just kind of get started this way. Now, let's go back here for a second. So if I want to maybe enter this competition, I could enter it and then create a notebook by hitting code. And then I can create my own notebook, but there's also everyone else who has submitted it and shared these. You can go through their notebooks. And that's one of the great values of this site, is that you can just spend tons of time looking at what people have done. So this person has gone through, and they've actually made a nice table of contents and all that for their submission. They've defined a data dictionary here. They're pulling in the data, looking at it, and they're checking right here. This is a validation. So
Excuse me for interrupting, but Clay, it seems that your audio is going in and out some.
Oh, okay. Sorry. Let me try to change that.
Okay, thank you.
Yeah, no problem. Let's see. Stop. Okay, I just switched my microphone. Does that sound any better?
You're definitely solid. There's a little background noise, but it is more clear.
Okay. Thank you. Yeah, so they're just they're checking for the number of nulls in any particular column. So everything's good, but we see age and cabin don't really have good, well, I shouldn't say that. It has some null values, and that may or may be a detractor in this case. And in fact, they've decided to drop these columns based on whether there's value or not. And they're using, well, they're actually keeping age. So I don't know if that entirely informed their analysis, or they were maybe using intuition, which is not a bad thing to use when analyzing data, because common sense actually accounts for a lot in the world of data. And just one more point on that, when you're working with data in the wild, and all of industry is doing that, probably the most important step is the first step, and that's validating or cleaning the data or preparing it to be used. Once you get into data that's collected in the wild, and we'll look at some stuff that's that the Louisville Metro government has published. Once you get into data sets like that, you really have to do some checking, and you might even have to fill in some gaps, or in some cases, if you're part of the research thing, get more subjects for your research if you don't have enough data. Okay, so they've decided to drop. They're not going to be useful for their analysis, and they're going to fill in the age. So the age had a lot of gaps, and they're going to fill it in with the median value of age. So they're just making that up in a sense, but if they use the median, then it has maybe a neutral effect. And now they check there is null again, and everything's good with the columns they kept. So this is kind of cool. I'm not going to go through the whole thing, but there's various plots and graphs that they've done to illustrate the data better. And we can look at this one here. And I think this is, they plotted this against survival rate. Okay, survived. Yeah. So you can see that, oh, no, actually, this is This is not against survival rate. So there's actually more males on the ship than females, and yet more females survive. So that's interesting. P class is, I think there's 3 classes of cabins. You know, some are very expensive and some are not. And I think the 3rd category is the least expensive. And embarked, I think, is the port that they embarked from. I'm not sure what those are, but there were maybe 3 ports prior to it going down in the ocean. But anyways, you can learn a lot just by going through these. And what's nice is you have a context for looking at the data. So it's not just I'm looking at the MNIST data set or something and I'm trying to build a model from it. It's like there's an actual purpose. So I'm trying to solve a problem. And that kind of gets you into the game a little bit more and gives you a little more incentive to, you know, take it further. Okay. Now, as far as like general data exploration, we can look at the data sets here, and there's a bunch of them, and there's some pretty cool stuff. One data set I was intending for this was the General Sociological Survey, GSS. There we go. And when you click on the data set, you're going to get, well, this is like a data dictionary here. And it will show you some stats. Sometimes it shows like part of a data frame. Oh, here. Actually, no, it will show you the actual CSV. It'll give you a little bit of the CSV there. There's like 12,000 plus columns in this, so I'm not even sure you could. Yeah, they're just gonna show like 10. Oops. That. Oop. Sorry about that. So with these data sets, you can work with them right in the Kaggle website. And so I'm going to create a new notebook. Unfortunately, I I had built a notebook that I wanted to demo with this data set, and I was trying to clean it up, and I deleted the whole thing. So be careful. But this does the same thing. It shows you the file path, where the data set is. As it happens, because this data set is so large, it's you cannot load the whole thing in a pandas data frame. You'll run out of memory. So you have to use a few tricks to get that going. And let's see if maybe we can just, you know, look at that real quick. It is slow. I don't know if this is my internet speed or what, but I'm guessing that they're just not giving you that much. In fact, you can see they have these metrics here. So the CPU, I'm almost maxing the CPU just to crawl the files. Well, it's not going down now. I don't know. Maybe that's always like that. Okay, so we'll do we've got pandas. Okay, we'll do df equals p csv and this. There's a few things that I'm gonna do. Well, okay. first I'll just do, this is a way to limit the amount of data you're getting. So I can't remember, there's maybe 20,000 rows. We're gonna take in just 10, just give a quick sample and see what happens and hope that expedites the download. Oh, I forgot to. Okay. So here's something interesting. And this was in the data dictionary, it mentions this. So there's actually, the first two columns are kind of indicating the row. I mean, the header. So we have these long form names here, which are a little bit unwieldy, and that's currently the header. So if I did something like, so another one, if I did something like this, oops. Actually, you know what? Let's do this. Let's do a shape. We'll just see how many columns are in there. Shape. Oops. Yeah, there's almost 12,000 columns. But there's these nicer naming conventions on the first row. So the first row could actually be the header row. So what we're going to do is we're going to specify the header row is the first one. And this is just because I kind of wanted to use the year, and it's coming through as a string. This is something I know because I've already checked it out. I'm going to set this up to be a string type. I mean, sorry, an int type. Let's see, I think it's capitalized. By the way, feel free to shout out to me if I'm doing something wrong or I missed something. Okay.
This is kind of what I find really fun about these events is watching people do this in real life and saying, hey, they make the same sorts of errors that I do. So obviously I'm doing it correctly, because the professionals are doing it like this.
I Google everything. And so I'm trying not to do that for this demo, but my instinct is to Google everything. The reason I'm specifying this, it's kind of a quirky thing. It doesn't necessarily mean what you think it does, but the reason I'm doing this is so that the rest of the types are set automatically. It will create an error if you don't do that. Okay, let's see if I did this right. Okay, what did I do? Has no attribute. Okay, so it must be int. Okay, so now we've got our year and all of these. Now, there's plenty of unnamed columns, but interestingly enough, at least from this small sample, they also don't have values. So I'm not sure what that is. Oh, I know what that is. This survey takes place over many years. So I think it started in 1972, and this data set has all those years. So I think they've added questions to the survey. So in 1972, you might find a lot of these that don't have any particular value. Yeah. All right, so let's just see. Let's see if we can explore something here. Let's see. This is a big guess here. Actually, I have. No, wait. I have an example that I'm just going to pull up here. Okay. Okay. As it happens, I was using the reason I was interested in this data set. I have been reading this book called Think Bayes with Bayesian statistics. Really great book. They go through using data frames to parse out statistics and explain Bayesian theorem. And they're going with this classic. I'll just read this. They're going with a classic proposition from some famous research. Who are the researchers? Well, I'm not seeing that. But Linda the banker is a 31-year-old, single, outspoken, and very bright. She majored in philosophy. She was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which is more probable? Linda is a bank teller, or Linda is a bank teller and is active in the feminist movement? Anybody know?
We'll go with A. Linda's a bank teller.
Yeah. Who answered that?
I cheated. I've read the book or part of it.
Oh, good. Did you read that book?
Yeah, part of it. It's a good book.
The one that was originally published with the research?
No, I think Alan Downey's. But yeah, it's a fun question.
Yeah. Well, it's kind of a trick question. So, if somebody is a bank, like, it's a higher probability, obviously, that someone is a banker rather than they're a banker and they like McDonald's, right? Because that's always going to be a subset of that population. Okay. So Indus 10. All right. Indus 10 is industry 6870. Indus 10. And that just means the industry you work in. And there's a whole coding system for this, which wouldn't be obvious unless you did a little bit of research. So let's try that out. Oops, what happened? Key error. Okay. Well, I didn't have the right key. So sorry about that. Maybe we can look at the keys here. Let's see. Oh, sorry. VF. Let's see. Just try. Indus. Okay, there's an Indus 7. So let's try that.
I think it might be Indus 07.
Okay. Good call. There you go. Now there, I only grabbed how many did I grab? Like 20 or something. So it's not there. In the notebook that crashed, I had kind of built code to just pull out 1 year from the data frame, but that we don't need to go through all that. But this kind of gives you an idea of, you can use these notebooks regardless of being in a competition, and you can explore the data sets and see a lot of sample code. One interesting thing, let's see if we can look at that, is so if I click on, let's see, okay, so if I click on any particular piece of code, it's going to bring up references into the shared notebooks, and that's a really interesting way to kind of do further exploration. Oops, I didn't mean to do that. Here, actually, I'm going to go back to looking at Titanic here, data, notebooks. Oh, here's a cool one. Sorry, I got distracted.
Now I feel better. If Clay gets distracted,
I
I
get
go on
so
rabbit.
distracted.
Going-
Sorry.
I go in rabbit holes.
Okay, data sets. Okay.
Rabbit holes are definitely the best part.
For some reason, it's not coming up, but that whole list of workbooks related to the competition is what I was trying to get. Actually, you know what? I'm going to go back into. I just want to kind of demo this code linkage here. So let's say you see an interesting method, like, what really is going on here? You can highlight this stuff. Well, it's not working now. There. So you can click on it, and it's going to find references in other notebooks. Or it should. Beep, boop, beep, boop, beep, boop, beep, boop. All right, well, I'm just going to let that load up. Okay. One thing I wanted to highlight here is, pandas is probably the go-to for most of the stuff. There's 3 kind of central places to see documentation in pandas. I mean, it's all under the API reference, but most of the methods are attached to data frame or pandas itself, like read CSV is right off pandas. We could just search for that. There we go. So these are all the methods directly off pandas. And then there's Panda series. And it has its own methods and logic. So a lot of times what will confuse people is trying to use a data frame method on a series. So just be aware of that. Let's see. Okay, so I created this Colab notebook to look at some Louisville data here, and this is the link to Louisville's open data. I think this is in our syllabus, and you can just start searching for data here. This takes you to a list of various data sets. Let's see. Would this be interesting? I think these numbers are indicating how large they are. Actually, I'm not sure. No, that doesn't make sense. Well, we'll just, we'll gamble here. So we'll go to this, and oh, there's a whole bunch of them. Okay. Well, I'll show you that in a sec. So I grabbed this one, which is land bank sales for the past 5 years. And I think the city owns various pieces of property, and you can get the, this has the data on the sales. So I pulled this in using requests, which is an HTTP library. I got this link. I'll show you how to get this link for any data set, but it just kind of made it a little bit easier. Actually, you know what? Let's look at this, just this alone. Create a new one of these. Oh, we put it up here. Okay, that's fine. So what happens when we pull this in? I think it's content. Content. Yeah, it's content. Okay, what we get is, it's actually a bytecode string, but you can read it. So it's a comma separated text string. It's, you know, essentially a CSV, but not in file format. So you can take this as is and put that into a data frame, which I've done up here by using this method. Now, I'm taking the content, I'm decoding it to UTF-8 from the bytecode. I'm putting it into a string IO, that's a reader, and then plopping it into the data frame. And then we're doing validation and inspection here. So what do we got? LBA is the Louisville Land Bank. That's the owner. This is the street, postal direction, blah, 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 blah. Parcel number, neighborhood, council district, and the sale amount. So you could, with this data, you can audit the city if you feel like it. Here's a good method to just kind of get some basic stats on the data. Describe. So anything that's a numeric column is going to have some stats they're going to apply. Now, as it happens, they're running stats on postal codes and other things because they came in as floating point numbers, which is, you know, totally meaningless. So this would be, you know, something that this was just for demonstration purposes, but you might say, okay, well, maybe I should conform this data to non-floats, you know, for the purpose of my investigation. DF shape, so it's got 474 rows. Maybe I'm thinking that's, you know, not enough data. And as it happens, there's another set that's paired with this for historical data that you could combine them if you needed more data for your analysis. I thought I would just, demo a little plot here. Now, this is a terrible data set for doing it, but nevertheless, this is nearly directly copied from the matplotlib documentation. So it's just building out a little histogram, which is, not so significant in this case. Okay, so back to getting some more data here. Let's see, COVID-19 daily financial report. Okay, so I want to download this, but I kind of want to skip all that process, and I'm going to go into my browser here and look at the network tab, and I'm going to download. So even before I download, I get this link right here. So I'm going to cancel that, and I'm going to go in here, and there's the URL for that data set. So I'm going to copy that value. I'm going to take it back to my notebook, and let's, create. Now, I thought there was a way I could, wait, if I'm down here, okay, there. I thought there was a hotkey for creating a new little paragraph, but anyways. So this is and this code up here. This method, the Google Colab import files, that's for, I think that's what that does is you can upload a file or a data set into the notebook for later use. These happen to be small enough, it doesn't really make sense, so I'm not going to worry about that. Unicode error. Oh, it's XLSX. Okay. Wow. I might have to Google that. Let's see here. XLSX. Okay, that's probably a deal. That's a deal breaker. I would probably have to. I could turn it into a file object. That's pretty tedious. This is something I'd probably have to download, and let's see here. Let's just find another one. I guess I have to pay attention to what the file format is. Oh yeah, XLSX. CSV, real property donations. Now let's find something else. Nope. Species. Animal service intake and outcome. Animal service activity log. Environmental health bulk data. That sounds interesting. We'll check that out. Okay. Now, this is interesting. It has a link to CartoDB, which is a mapping company, and they have web-based map browsers. But When I did this before, it didn't really do anything. I'll just try for kicks. See what it does. No. So somehow it's not linked, but that would be super cool if it was. Okay. Oh, wait. These are subsets of that. Inspections, bulk data, establishments, bulk data, animal bites, bulk data. Yeah, let's check that out. Clear. Oh, that must be a big data set. It's taking a while. No? Okay. Hey, people have gotten bit by skunks. Wow. That sounds pretty wild.
My dad had a cousin who was bit by a mole. We're still not sure how that happened.
Okay, well let's actually see if we can find mole bites in here. That would be fun. or let's look at the various species that have given bites. Okay, so let's see. What is it? Species. ID. The ID description. Somehow it's giving me a little error there. No. Okay. Oh. Okay, we've got skunk, dog, bat, cat, ferret, unidentified, horse, raccoon, other, and rat. Let's see.
Now
Maybe
we need the probability question of what's the order of most to least number of bytes.
Yeah, there we go.
What does everybody think? Post in chat. What are the top 3? Post in chat.
Well, not surprisingly, it's dog and cat. I'm not sure a cat bite's worth reporting, but many people have been victim of that.
They can get super infected, like easily. Cat bites are nasty.
Oh yeah.
And I say that as the servant to 3 house cats. So yes.
Ferret. See, that's interesting. I mean, where are all these ferrets? I've never even met one. Yeah, so actually here, let's try our little plot thing with that.
It'd also be interesting to see, is it 16 ferrets or 1 ferret went on a rampage and bit 16 people?
Yeah, good question. Does anybody know how to is there somewhere I can click to make a what do you call it, paragraph below this. Oh wait, here we go. I just have to hover below. All right, let's see what happens there. Improvements. Oh, right. Well, let's see. What's something that we got a numeric value for? Nothing. Okay, well that wouldn't work then. Wait, vaccination years. Yeah, okay. We'll do vaccination years. Or we could do well, that wouldn't apply. No. Vaccination years. Oops. Vaccination years. Is that right? Vaccination, YRS. And it's got 2 C's. Well, it's either 1 or 3. So that's also not so interesting, but not too many good numeric values there. Yeah, I think that's all I got. And sorry for being so disorganized. My plans kind of got messed up a little bit, but let's do some question answers. Stop share.
We had one question from the registration on if, obviously data people work with data sets, but are there other types of programming where having a good knowledge of using data sets would be helpful?
That's a great question. I think, anything in the engineering field is going to touch data, but not necessarily in the analysis side. However, just being, from my experience being, sorry, the wind's starting to blow. I'm going to close my door. Kind of feels like we're getting a storm here. Yeah, I think
And he disappears into the hills, never to be seen again. There he is. He's back.
Yeah, in my experience, sorry, working as a back-end engineer, often you have to understand the data. So in this case, it was like user data from our website, and some of the same principles that would apply to a data analysis or even statistician apply to anybody who's touching data. And that is, you need to validate it. You need to know it. You kind of need to know the process that created it, and you need to know when it's inaccurate or wrong or not useful.
Hey, any other questions from the audience?
Yeah, hi, I've got a question. How often do you use Power BI in data analytics, or do you use it at all?
I've used it a little bit. Our team is kind of divided into the engineering and the intelligence side, and I have moved to the engineering side, so I really don't use Power BI that much, but it's pretty popular in the industry, and a lot of people involved in business will use it, and so you often might need to support that format for sharing your data, just because it's so common.
Okay. All right, cool. And is it ever mixed? Like, would you people ever use Python to interact with it, or is it just kind of other stuff, or do you know that?
No, it's kind of, I mean, you might engineer the data in some way with Python to get it to Power BI, but you really mostly are working within the constraints of that software. And there's actually, other platforms other than Power BI, so I wouldn't necessarily just recommend someone to go learn it, unless that was part of the job you're applying to.
Okay, cool. All right, thank you.
I've got a quick question.
Yeah.
What would be, you talked about validating the data. What would be maybe 2 or 3 different things that you might look at first that might be telltale signs that there's something really wrong with the data?
I think, you could go in steps. And so getting the head operation, seeing the first 4 rows, that's a big step, because, often if there's nothing there, you'll find that out immediately. And also you'll see the columns and make sure that's what you expected. From there, you might want to do some samples. So there's methods to get a sample of data from a data frame that will kind of take a random sample so that you'll see more than just the first 4 rows, and you can kind of qualify it visually there. But then like the null counts is really good, because sometimes you have huge gaps in your data that you didn't expect. There might be, like sometimes somebody will share a data set with you, a filer, and the first 1,000 rows looks great, but then the next 10,000 rows aren't even filled in. So you have to check the extent of it. You can, one way to do that besides the sampling is to manually do that. Check the first 10 rows, check some middle rows, check the last rows. Then you might try to find out if there's a sequence to the data. Like, for example, the GSS, the General Sociological Survey, is actually the first so many rows is 1972, the next is 1973, so on and so on. So you can find that there's an order to how the rows were constructed. Let's see, the types, that's another thing, but that's something you can maybe change. But sometimes things are wrong. Like you might want to see, like, if you have a column that's labeled years, but you have like names in it. Well, that's clearly wrong. That has to do with like the source of compiling the data, and whatever you got, whoever compiled it probably did that wrong. So I don't know, Paul, can you think of anything else?
Those are all some great points. I mean, trying to normalize making sure every column is the same type. So making sure you don't have strings in your numeric columns. You mentioned that is good, and the NAs is great. Yeah, That's awesome. Great answer.
The tendency sometimes is, if you have a task or you're excited about doing something with data, is you get the data and you start doing the thing. But if you don't validate the data, you could actually, start building processes to analyze it and all this stuff, and then realize that, half the data is missing. So you want to corroborate that from the get-go, so not to waste time. And actually, sometimes whatever data set you've gotten, whether it was handed to you or you found for a particular purpose, sometimes it won't serve that purpose because it's too partial, or the values that you wanted are completely inaccurate. Like, for example, with the Titanic data set, let's say I had a theory. Maybe I read some history about the Titanic, and I knew that there were, a lot of young children on the Titanic. So I wanted to use age in my analysis, and I built up a theory that the children would have been saved first. But if I find that that column doesn't have good extensive data, or maybe data that covers the early ages, then it's completely useless for that analysis.
Any other questions? Okay, well, thank you so very much, Clay. This was a great presentation. It's always neat watching someone do this in real life, in real time, I guess I should say. And so, yeah, thank you again. And for everybody else, please continue to check out our Monday guest speaker series. Next Monday, excuse me, Code Kentucky is having another event with Flex Jobs talking about remote work. We're going to add that to the registration list because it just got finalized. So hope to see you all there. Thank you all very much and have a great evening.
Take care, everyone.
Thank you.